All right, and we're live. So we've got about 1 week left as of today, before the end of the course. So normally we'd be running through a bunch of formula quizzes, trying to get you ready. This year it's only for your response questions. It does look like I misread after all. You guys will have an opportunity to handwrite your assignments. You don't have to use the keyboard techniques. I still think it was worthwhile to learn them because if you want to type anything math related in college, you'll still be using the same format though. Um, so you guys can use your photos to upload. You're gonna have a timer that counts down once you go into your test. So you'll get there at 1:30 in the morning. There'll be a timer that counts down before your test opens. Your test will open and you'll have 5 extra minutes in addition to the time that you need for each section. That will be included in your time. So in your first 25-minute section, you'll have a 30-minute timer that counts down. When you hit the 5-minute mark, that timer will turn red. That's your indication that you need to stop working and start uploading what you got. On each of the documents that you upload, they are asking that you include some information. Yep. Let me actually go to the checklist, so that'll be faster. If you're handwriting your exam, on every page that you submit, you have to have a page number, your 8-character AP ID, and your initials. So I would do that before you go into the exam. So you can see that on your checklist here. If you do plan to handwrite anything, make sure you've got page numbers as well. That's because sometimes the photos don't get uploaded in the right order. So that will allow them to reorder your exam for the people who are reading it. Okay, so you've got 3 options for when you're submitting. You can submit handwritten work, which would be a photo of your handwritten work. You can submit a Word document or a Google document, any kind of other .docx, .doc, or .odf format document that you've typed out using the keyboard techniques that we talked about. Or they will have an in-web page text editor that you could use the keyboard techniques we talked about last class period as well, in case you can't get Word to work. Whatever is easiest for you, just stick with that. Okay, so I'm going to get back into this one. Okay, so I'm picking another interpretation of composite functions from a graph. They seem to be the ones that we're still scoring the lowest on, I think, overall. So I'm going to be looking for you guys to solve everything on your own first, since we're only a week out. And then if we need help, I'll start asking probing questions and stuff. So what we've got here is a graph of f prime, which is a twice differentiable function of f. We have horizontal tangent lines at x equals 1, 3, and 5. And the areas inside are labeled here as 2, 6, 3, and 7. The function is defined for all real numbers, and f of 8 is 4. Okay, the first thing we want to do, I'm going to label all of my x values here, since that'll help us out as well. Because it's harder to count if you guys don't have this directly in front of you and can't write. So the first thing we want you to do is to figure out when the function f has a local minimum, and then justify your answer. So I'm going to start with Junho this time. Junho, how can we figure out when this function has a local minimum?
The f prime is equal to 0.
Okay, f prime is 0. Um, I've got a couple options for when f prime is 0. At what x values is f prime equal to 0?
0, 0, and 2, 1,
Okay, at 1,
1, 3,
not 3,
what is it? Oh, 5.
not 5. This is the graph of f prime, not the graph of f.
Oh, then 4 and 6.
4 and 6. Okay, so this is a common mistake. Um, Whenever you guys have a graph on your free response questions, it's really important this year, especially now that your whole test is just free response questions. The first thing you need to do is check and see what your graph is actually of. So if you consider this to be a graph of f, then your entire rest of the question is wrong. So check this first. Is this a graph of f, a graph of g, a graph of h, some other function? Since we've got a g and an f prime mentioned, that'll change everything actually. Okay, so this is 1, 4, and 6 are all points where f prime is 0. What else needs to be true in order for this to be a local minimum of f? So you said in order to be a local minimum, f prime equals 0, and what else?
The second derive.
Okay, and the second derivative needs to be what?
Negative.
For a local minimum, if the second derivative would need to be positive. If we are concave up
Oh,
with a slope of 0, then we'll be at a minimum. If we're concave down, then we'll be at a maximum, right? Okay, so that's one way we could do it. The other way you could do it is to do a first derivative test, which means your f prime would change sign from negative to positive. Either technique will work. Okay, so if we need f prime prime to be positive, how could I figure out whether f prime prime is positive or negative based on this graph of f prime?
If the side's changing?
Say one more time, I'm sorry. I'm not saying you're wrong, I just couldn't hear.
When the side not changing. Oh,
Instead of changing. Okay, so I think you're using the second method then. So if your sign changes from negative to positive, then which one of these 3 points is going to be the local minimum?
one.
Okay, 1 is not a local minimum because, again, this is not a graph of f, this is a graph of f prime. I want a local minimum of f, not a local minimum of f prime.
So 6.
Okay, so 6 is okay. Because f prime, this graph, is changing from a negative y value to a positive y value, which means f prime is changing sign from negative to positive. Okay, back to Junho. If we wanted the second derivative of f, then how many times would I have to derive the graph?
1.
Once. Okay, so if you look at the derivative of this graph, you will get the concavity of f. At 6, is the derivative of this graph positive or negative?
Pose.
Positive, because the slope is going up, right?
Yes.
Okay, so the second derivative is positive of f, since the second derivative is the first derivative of our graph. And f prime is 0, since our graph is the first derivative, that's the y value of this graph is 0. Okay, any questions on what we just did?
No.
Oliver, are you okay?
Yes.
Okay. If I wanted to find a local maximum of f instead, what would I have to do?
Where change from positive to negative one.
Okay,
The opposite.
so which point would be the local maximum
4.
of f?
Where x is equal to 4.
Okay, cool. So the local maximum of f would be at x equals 4. What point would be the local minimum of f prime?
Of f prime.
Yep.
1.
Okay, 1 is a local
Or
minimum of f prime. 5 is a local minimum of f prime as well. Since this graph is f prime, then we're doing our normal minimums and maximums from a graph, right? If we're doing our local minimum of f, though, we're not actually looking at the minimums of this graph. We'll be looking for the minimums of the integral of this graph. So instead, we can break that down and say a local minimum of f would mean that the derivative of f is 0, which means this graph's y value must be 0, and that the concavity must be positive, which means this graph's derivative must be positive, which is only true for the point 6. Okay, part B. So we're on Oliver this time. Oliver, I want to determine the absolute minimum of the original function f on the interval from 0 to 8.
okay. But we already did that, right?
We found a local minimum. We did not find the absolute minimum.
Okay. So we have to prove the search the values of 0, 1, 4, and 8.
Okay, of 0, why 1?
Because f prime is equal to 0 there, so it has to be a extrema for y.
Okay, so
For
you're
f.
testing all extrema. At x equals 1, is that a local minimum, local maximum, or neither of f?
Local.
So options are minimum, maximum, or neither of f.
Neither.
Neither.
Local.
So this is actually just a point of inflection. Our original graph did something like this at that point. So we did hit a slope of 0, but then we kept increasing after that. So I don't need to test 1.
Okay.
If I'm looking for the absolute minimum.
Oh, So we have to test 4 and 8.
Okay, I'm gonna label these again. 4, 5, 6, 7, 8. Okay, so at x equals 4, would that be a local minimum or maximum?
Maximum.
Maximum. Okay, I'm looking for the absolute minimum, so we don't need to test 4 either.
Oh, okay, so 6 and 8.
6 and 8. Okay, so now I need an equation in order to get the y value at these points. So Junho, I'm back to you. We know that f of 8 is equal to 4. How can I get from this point to our value at 6?
The interval 6 to 8.
So right now we're at 8,
6.
so I'm actually going from 8 to 6. And then what am I integrating?
Oh, f prime of x.
F prime of x dx. Okay, that's perfect. If I'm adding an integral from 8 to 6, then that means I can rewrite this. If you flip your bounds, you'll change sign. So that's the same thing as subtracting the integral from 6 to 8. Okay, what's the area between 6 and 8?
7.
7, okay. So f of 6 is really 4 minus 7 is negative 3. Okay, Oliver, same idea. I need to know what f of 0 is. How could I get to f of 0?
Is 2? Oh no, it's 0.
Let's work out our steps though, because we're gonna need to show our work. So how do you get to f of 0?
Well, I'll look at the graph. Oh. No.
Okay, we have a start point at f of 8. What could we add to that in order to get to our y value at x equals 0?
Well, x equals 0 is the starting point, so it should be 0.
We don't know that. Because we weren't told that the start point is 0, we were just told that f of 8 is 4. So it's possible we didn't start at 0.
We count the y value at x equals 0.
We don't have the original graph is the problem. So how would you get to the y value? Okay, I'm gonna take a look down here at what we just did for Junho in order to get f of 6. Taking a look at this.
Well, I don't see it. It's not updated.
Okay, let me send through each app.
Okay, thank you.
So in order to get to a y value, you can take a start point and add your change in y.
So we. Okay. So we use f of 8
Okay,
plus the integral from 8 to 0
okay,
f prime x.
perfect. And when we integrate that, that will end up giving us the change in f from 8 to 0, which is what we want. Now I'm going to break that down. First, our bounds are flipped. So I'm going to change our bounds again. So to go from 0 to 8, anytime you change your bounds, anytime you flip your bounds though, that will change the sign of your integral. So this will become f of 8 minus the integral from 0 to 8 of f prime x. And then if we integrate f prime, that means the area underneath the graph that they gave us. So we'll need to add the areas. Okay, so what's the area from 0 to 8?
Um, so f8 is 4 plus the integral from 8 to 0 f prime x, which
Okay.
is, wait, go to the problem again.
Okay, I'm sending another through WeChat just in case you can't see the video.
Okay, thank you.
So we had f of 8 plus, you're right, the integral from 8 to 0 of f prime x. If I want to do that from left to right, then we can reverse those bounds. But anytime you reverse the bounds of an integral, you'll be subtracting that integral instead of adding it, so the sign will change. So this becomes f of 8
Okay.
minus the integral from 0 to 8 of f prime. And now I can just add all the area from 0 to 8 for our graph. So what's the total area from 0 to 8?
8, 16, 18.
Some of that area should have been negative.
Oh, okay, so 5, 13.
5 plus 7?
14.
12.
Oh no. Okay.
So f of 0 then is 4 minus 12 or negative 8?
Yeah.
Okay, over to Junho. As I pass this back to Oliver. Okay, so justify your answer and determine the absolute minimum. I guess I didn't really answer the question yet. We did all the work for it. So Junho, let's finish this off. What is the absolute minimum value of f?
It's 0, x equal.
Okay.
Actually, minimum occurs at x equal negative 8. X equals 0.
Is it x equals 0? Okay. On the closed interval from 0 to 8 included. Oops, 0 to 8. Okay. And we've got enough justification in our work that we should be okay. Okay, for part C, I want to know on what intervals is f both concave down and increasing. Okay, I'm going to go to Junho. Can you give me two intervals for this function where the original f would be concave down based on the graph of f prime?
Keep down. So is 1, 2, 3, 4.
Again, this is a graph of f prime, not the graph of f.
Oh, wait, then 3 to 5.
3 to 5. And one more.
And
I'm looking for one more interval where f is concave down based on this graph of f prime.
oh, 5 to 8.
From 5 to 8, we're concave up, since the slope of f prime is positive. If the slope of f prime is positive, that means f prime prime is positive, which would mean f is concave up.
0 to 1.
0 to 1. Okay, so those are all the intervals where we are concave down. If that's true, we're concave down on 0 to 1 and 3 to 5. Then on these intervals that you told me, Oliver, where would we be both concave down and increasing for f?
Can you send me a screenshot, please? Yeah.
Yep. We're on part C.
Well, from 1 to 3.
From 1 to 3, we are not concave down. Okay, guys, this is not a graph of f. This is a graph of f prime. So
Okay, sorry.
in order to get the concavity of f, we'll need to be looking at the slope of the graph that they gave us.
Well,
If we,
it will be concave. What? 0 to 1. From 1 to 3.
from 1 to 3, f will be concave up, because the graph of f prime is positive. If the slope of the graph of f prime is positive, then that means f prime prime is positive, right? Since f prime prime is the concavity of f, then we'll be concave up. If you derive f, you'll get f prime. If you derive f prime, you'll get f prime prime. Our graph is f prime. So that means the slope of the graph is f prime prime. Okay, that's the concavity of f is the slope, the first derivative of f prime. The y value of our graph is this, the slope of f, the original graph that's not shown. In the original graph f would be the integral of the graph to get the y value of f. So the graph that we have before us is f prime, which is the slope of f. If we derive the graph, if we get the slope of this graph, we'll get the concavity of our original function f, since the derivative of this graph will give us f prime prime. Okay, Oliver, back to you. When is the graph of f both concave down and increasing?
From 0 to 1.
Okay, from 0 to 1 is good. And do we have anywhere else? Junho, can you give me one more?
Three to 4.
Okay, 3 to 4 is right. Junho, how do we know that f is increasing from 3 to 4?
Because the graph of f prime shows that they're positive.
Perfect. The y value of this graph is positive, and since this graph is a graph of f prime, that means f prime is positive between 3 and 4. Because f prime is positive, that means the slope of f is positive, so f should be increasing from 3 to 4. Okay, any questions on what we did here?
No.
Okay, I'm going to add to my explanation then. So f is concave down and increasing on 0 to 1 and 3 to 4 as f prime is decreasing. That's what told us that f is concave down. And f prime is positive on those intervals. The y value of f prime, our graph, is positive. That tells us that f is increasing. And our slope of f prime, that's the slope of this graph, is decreasing from 0 to 1 and 3 to 4, which tells us that the original f is concave down. All right, any questions on A, B, or C so far?
No.
No.
Okay, over D. Our function g is defined as a composite function. G of x is f of x cubed. If f of 3 is negative 5 over 2, I want to find the slope of the line tangent to the graph of g at x equals 3. So if I want the slope of a line tangent to g at x equals 3, what information would I need to find first?
What fx?
So I want a line tangent to g of x at x equals 3. How would you write the equation of a tangent line to g of x at x equals 3?
F prime cube F F of B cube.
F of 3 cubed would give me the y value. So I could say g at 3 is f of 3 cubed is one piece of information I need. So that's negative 5 over 2 cubed, or 125 over 8. Okay, I've got a y value for g. What else do I need in order to get a tangent line?
The slope.
Okay, the slope of g at 3. So what is the slope of g at 3? What is g prime at 3?
3 times fx.
Okay, 3 times f of 3 raised to what power?
2.
2. And then chain rule times
F prime B.
f prime at 3. Perfect. Okay, so we'll substitute 3 times f of 3 squared. So that's 3 times f of 3, which was negative 5 over 2 squared, times f prime at 3, which is based on our graph. What is f prime at 3?
Uh, 4.
4. Perfect. Okay, so when I square this will become 25 over 4. The 4's will cancel. So I've got 25 times 3 is 75. All right, any questions on part D?
No.
Okay, let me send this to Oliver really quick. Okay, I do still want to do more of these because we're still struggling here. So I think what I'm going to do is for the next class period, I'm going to go through a bunch of free response questions and just pull these ones. So your homework for next class period on Thursday will just be this type of problem where you're interpreting graphs. I'm going to let you use any notes or anything that you want for the homework. And we'll probably count that as another quiz grade. I am grading your tests right now that you did through AP Classroom. Oliver, I don't think I have yours submitted yet. So please get it to me when you can. Couldn't access, or?
Yeah, because of the Wi-Fi.
Okay, cool. So just get to me when you can.
Okay, thank you.
So for our actual time in class, next class period, I'm hoping to go through one more problem like this a little bit faster than we did today. So at some point between today and next class period, take another look at everything we did today through the PowerPoint and the annotated one, and just be ready to do another problem that's like it. And then after we get through that, I want to go over some of the test questions that we got wrong.
Okay.
Okay. Anything else you guys want to talk about before we break?
No.
No.
Okay. I do need you guys to start studying, so we're about a week out. If you want more free response questions to work through, I can send you more free response questions. But I think it would be beneficial to go back through the previous questions that we've done. If you want study guides from any year that we've done so far, I can send you the scoring guidelines, which have all the answers, plus the way to score yourselves, if you want to use that for practice.
Okay.
Since I did just get 2010 from you guys, I'm going to send you guys the scoring guides for that year. So you won't have to wait on me to score yourselves. That was here. For the 2010 Form B. Okay. Thank you guys for coming, and I'll see you on Thursday.
I'll see
Okay,
you.
thank you.
Bye.